Welcome to Fast Reach Tutors. Don't forget to subscribe to the channel, hit the bell icon, and please leave your comments for new videos.
So in this section, we're going to be looking at the limit of a function. So the notation, limit, the limit of fx as x approaches a is equal to L is read. The limit of fx as x approaches a equals L. And it means that the value of fx can be arbitrarily made close to L by choosing x sufficiently close to a but not equal to a. But the limit of fx exists if and only if the limiting value from the left equals the limiting value of the right. So what this means is that if you take values from the left and from the right, and if they both come to the same value, then there is a limit. If they don't come to the same value, then there is no limit. So this is an intuitive explanation of the limit of a function. A more precise definition using inequalities is important for advanced work, but it is not necessary for our purposes. So we're going to look at this example. Determine the limit of y equals x minus 1 as x approaches 2. So as you see, we have values from the left approaching 2, and then values from the right approaching 2. So what we do is we put the x value into this equation and then find out the limit. So let's do that. So here is an Excel where I have the same chart where x is we have values from the left approaching 2 and values from the right approaching 2, and we're going to substitute these x values into this equation. So if you do that, you do equals this. The square is the same as multiplying it by itself, and then put a bracket of this one and this one, and you're subtracting 1 minus 1. So you get 0. So if we do the same thing over here, I'm just copying and pasting. So as values get closer and closer to 2, what value do you get? As you come from the left side, it's coming to 3, and the values when it's coming from the right side is coming to 3. So the limit is so it is equal to 3. So as x approaches 2 from the left, starting at x equals 1, what is the approximate y value? So we found that as we approach, we get closer to 3. And then as x approaches from the right, starting at 3, what is the appropriate value of y? So it's 3. So graph x squared minus 2 using software or graph paper. So let's graph y equals x. So if we look at 2, as if when we come from the right side towards 2, it's at the y value 3. And if we come from the left side towards 2, we get the value of 3. So if we look at, I showed you on the graph as when you come from the right side and the left side, the y value is getting closer to 3. So explain why the limit of y equals x squared minus 1 exists as x approaches 2 and give its approximate value. So the approximate value is 3, and it exists because both the so we're going to look at this example. Determine the limit as x approaches 1 for x squared minus 1 over x minus 1. So we're going to use a graphing calculator. Okay, so we're going to draw the graph. So I've put that equation here and I've drawn the graph. So what we need to do is using this graph to determine the limit for as x approaches 1 from both the left side and the right side. As we go from the left side to 1, we see that the value is approaching 2. If we go from the right side to 2, 1, the value is also approaching 2. So since the limit on the left side equals to the limit on the right side, we say that a limit exists. Let's look at the next example. So selecting a table of values strategy to evaluate a limit. So we are given that same function, but this time we're going to use this chart. So I'm going to open an Excel. So here we're selecting a table of value strategy to evaluate the limit. So determine as x approaches 1 for x squared minus 1 over x minus 1. So here we are showing 1 negative means coming from the left side to 1, and then 1 positive means we're coming from the right side to 1. So what we're going to do is put 0 as x in this function and figure out the value. So 0 squared minus 1 is minus 1, and so we can actually do this. We can do a formula so that it can do it by itself. So 0 times 0 minus 1. I'm going to put that in brackets. Divided by bracket, 0 minus 1, and you get 1. Okay, if I copy this form, so the same thing I would do, I would substitute this value as 0.5 in this formula, so 0.5 squared minus 1 over 0.5 minus 1, and put the values into this equation like one by one, and then find the corresponding value of y. So I'm just going to use the formula, and it's going to tell me so did I do this formula right? Equals 0 times this minus 1 divided by this minus 1. You get 1. And move this over. Okay, so and if we put 1 into the equation, we get 0. Okay, so here when we put these values into this formula, we see that as you come from the left side towards 1, you get closer to 2. And when you come from the right side towards 1, it gets closer to 2. So since the limit from the left side and the limit from the right side are equal, a limit does exist, and the limit value is 2. And here they're doing the same thing. Yeah, they show that it's undefined, and here the formula said the same thing. It means it's undefined because you cannot It's undefined because you cannot divide by 0. So here, this pattern of numbers suggests that the limit as x approaches 1 for x squared minus 1 over x minus 1 is equal to 2, as we found when graphing in the example 1. Selecting a graphing strategy to evaluate a limit. So sketch the graph of the piecewise function. So fx, so x minus 1 when x is, when x is less than 1, 1 if x is equal to 1, and then 2 plus square root of x minus 1 if x is greater than 1. So when it's equal to 1, fx is 1. Okay, let's use a graphing software. So you copy this? No. Okay, actually, we'll just look at this example. So x minus 1 if x is less than 1. So here in this graph, if you use the function x minus 1, if the value, I've graphed it using this Desmos graphing software, and this is the 2 plus x minus 1. This is the x minus 1, and this is the x equals 1 graph. So if we're going to be finding the limit of 1, if you come from the left side, this left side, what is the limit of 1? It's 0. If you come from the right side, which is this graph, it's 2. So since the limits are both different, a limit doesn't exist. This graph is not continuous like this. It stops at this point, but I wasn't able to remove it. So I can show you the textbook. So if we look at this example, if we look at this example, which is fx is equal to x minus 1 if x is less than 1, and fx is equal to 1 when x is equal to 1, and fx is equal to 2 plus square root of x minus 1 when x is greater than 1. This is how the graph looks like. As you see, the graphs are not continuous. They all stop at 1. So from the left side, you can see that from the left side, the limit is approaching 0, whereas from the right side, it's approaching 2. And since the left side limits and the right side limit are not equal, the limit does not exist. So a limit only exists if the limit from the left side is equal to the limit from the right side.